We've just sort of said, yes, that should be migration. This should be a really nice pattern for that. And I haven't given you enough information about how to do this yet. So with this wind pattern on screen, where do you see that migrants will really stop along the swath of north winds? So we talked, it's nearly the same time as that previous image that we were messing with. I did it to you on purpose. I changed the image so you could get a different view of this and have to try a little harder to get this done. Take a look at this. Try to come up with some ideas of where you think birds will stop based on this wind pattern. Look at it for a bit, talk to your neighbor if you have someone in the same room who's doing this with you. We'll get to the voting, Emil, in just a minute. I appreciate that you're throwing them into the chat window. Don't put them there yet. Thank you everyone for being on board already and just joining in the fun and going for it. I appreciate it. The question at the moment is just, where do you think on this wind pattern, do you think birds will actually stop? I'm not asking for you to answer that question in the chat window. We will ask that question in a poll everywhere question in just a minute. The poll everywhere question that I'm going to start with, though, is different, because I want you to think about what is going on in these wind patterns that I'm going to show right now on this slide. Which of these wind patterns would cause higher concentrations of birds at your location? Your location in each of these instances, in A is right here, in B is right here, C is here, D is here. The arrows represent the winds, so the directions change with the swivel of those arrows. The length of the arrow is meant to be the speed of that wind. If the length is shorter, that means it's a slower wind. Take a look at those and throw in your answers when you're ready. I believe you should be able to answer this question twice. So you should get the ability to vote twice. So I'm probably going to expect more like 80 answers if people are using their 2 answer options. And we're flying through the 40s, we're into the 50s, keep them coming. Linda, you should be able to answer this question on pollev.com/CFOBirds. Again, pollev.com/CFOBirds. Getting into the 70s, great, keep them coming. And we'll start showing the responses to see how people have guessed or educatedly guessed. Here's how we see it. A and C are currently in the lead. The correct answers are A and C. Both of these are types of convergence, as we would call it in meteorological terms. The upper one is what we would call directional convergence, because the directions are all sort of coming together to lead to that one point. In C, that is actually speed convergence. So it's like what happens when you're coming up to a traffic jam. There's an accident ahead of you, everyone's coming flying in and they have to slam on the brakes and everything slows down and gets sort of compacted into this smaller area. So the speed convergence there is like a traffic jam, and the directional convergence is like an on-ramp. You're bringing more people onto that road, if that helps you. Lisa, I can try to speak more loudly. I'm already doing a good amount of that, and I'm a loud person, so I don't want to overdo it for other people. Thank you for throwing it into the chat window, though. I appreciate that you're trying to get a fix. Okay, so we've just talked about how convergence looks in a theoretical sense, but the atmosphere is a little non-theoretical So let's take a look at what it looks like in the atmosphere. This is that same map again. I want you to think about if you're changing your vote from what you were thinking the answer was before. Do not write it in the chat window right now. The idea is that we're going to jump into the poll everywhere question here in just a second. I want you to be looking for speed convergence and directional convergence. If you can find both of those happening at the same time, you're probably getting close to the right answer. Again, like it was previously, it is just going to be the state where it's occurring. I'm not going to try to pinpoint exact locations or have you click on the image to show me where you think that is. Figure out what state you think this is going to be occurring in, where the highest possibility of migrants stopping there will be, and we'll go to the question right now. Of the following states, which had the highest possibility of migrants stopping there? Take your time to answer that. You should get one answer only for this question. Yes, it does say 5 responses. I set this question up differently. Please only vote once for this question. Thank you, Stephanie, for throwing that out there. I rewrote the question and then didn't change the number of responses that you're allowed to do. Please vote once. If you do need to revoke votes, there should be a button that says clear last response underneath the question or underneath the answer field. If you click that a good number of times, all of your votes will go away and then you can just revote that one time that you should get to vote. So we should end up in this 40-ish range once again, and here we are at 40 votes. So moving forward into the responses. Here are your anonymous responses. I've got Texas, Kansas, Iowa, then Nebraska in order. No Colorados, no New Mexicos. Let's talk about the answer. Oops. I need to go back to talk about that answer. So what do we see going on this loop? We see that there is directional convergence going on in this Kansas area here. You can see those winds are really coming together. They're funneling down into a funnel. I mean, I can't say it any other way. That's the best word for it. So it's definitely funneling in the Kansas area. You can see it from even all the way out here. We're starting to funnel down into this area. All of the flow through here is funneling inwards as well. Kansas looks like it's a really good bet. If we move further to the west, though, you can see that these winds come down and converge into this area in Texas. The question becomes, since you have already picked Kansas and Texas as the majority correct answers, which one is more convergent, or which one will get more migrants? And I need you to think about that for a second. I'm not going to ask you a question about it. I need you to think about it from the perspective of funnels. All of these birds are in theory coming in along these north-ish, north-like winds. Where would they get funneled more though? Because this is the tough question that needs to be answered. This is not the easy part of this task. That's why I'm spending more time on this slide. If you think about the amount of birds that are crossing a given line, and by a given line, I mean one that is perpendicular to the wind. So let me draw one here for you on screen. If we were to draw a line from here near Cheyenne up towards northern Minnesota, International Falls sort of area like that, if we draw a line across there, the birds that are crossing that line going to the southeast initially, and then curving more south, and then headed more towards this Texas curl. Where is it happening where the initial width of that line that you choose your line however big you want it to be. If you follow the winds, maybe they're coming down and they're getting jammed into a smaller spot. So they've gone from a wide spot to a thin spot. So let me give you an example, because I know this is a really tough concept. Let's say we take the winds right across here from southwest South Dakota to north central South Dakota. And we follow those winds southward. So all of these winds here, I'm trying to keep on them. We end up condensing those down into about this area right here. All of these birds that were in this line would end up getting funneled to about this location. Yes, one could argue they do get funneled all the way down to Texas. Not going to argue with you about that. Let's look at another location. Let's look at Texas from the perspective of those winds on the west side here. We have north winds. If we draw a line from Cheyenne to North Platte or so, draw a line there, and you see that these winds are nearly the same width, and then they finally get jammed into this location approximately down here. Which one of those would end up with more birds in it? That's the question that needs to be asked. It's a little different than the question that I started with, which is which state has the highest possibility of migrants. But at this point, now we're getting to, I've started from a big area and now jammed all of those possible birds down into a smaller area. So it actually looks like, if we divide this into sort of the areas that I've looked at before, these winds in eastern Colorado going down into Texas versus this large swath of winds here that are getting jammed down into this line in Kansas, the answer might be Kansas. The answer could also be Texas, though. This is where this whole entire process gets really, really messy. I don't have answers to this question. I cannot tell you exactly what's going to be the best spot. The major problem we're encountering here is precipitation. There is likely a lot of precipitation occurring with this system. In this case, there is actually precipitation that is probably over approximately this whole area that I'm outlining right now on screen. This is a pretty potent system and has a good amount of precipitation associated with it. I'm just not showing it to you right now. When there's precipitation during a migrant's path, they tend to want to come down to the ground and land. It's a pretty big waste of energy for them. It doesn't mean that they won't fly through precipitation, but it's sort of a sketchy area that we don't really know how it works yet. Bill's talking things on the chat. I was just thinking of Bill when he goes and tries to chase Ross's gulls. I wouldn't say that he was chasing it. I shouldn't say that he was chasing it. He got lucky and found in really heavy snowfall a Ross's gull. Those are the types of things that still do happen in precipitation. It's just much harder for us to be able to predict. So Bill, now I'm going to get to your question. Kansas may be also more in line for boreal migrants in this example. I can agree with you. I would say Kansas is giving you more of a possibility of the boreal migrants coming from Canada, as opposed to the smaller subset of birds that might be able to come from the sort of Montana region. You're getting a smaller source in the Texas case. You're getting a larger source in the Kansas case. So that's another argument for why Kansas makes good sense. I just covered a lot. Are there any more questions about that before I move on to the actual American golden plover example? Take your time to throw it in the chat window. If you're feeling saucy and you want to unmute yourself, feel free and throw a question out verbally. Okay. Thank you again for the questions, comments in the chat window. It's much appreciated. And thank you for playing along with all the questions. So let's return to this bird, the American golden plover, and see what we can see with the pattern that produced 11 sightings of American golden plover in Colorado. I'll answer those questions that just came in from Sally. I'll answer that once I get to the next map. And Larry, I'm not sure I understand what is happening with the south winds. Let me touch another map for you, Larry, and maybe we can have that conversation. Maybe I can clarify. And Colleen, let me read your question. Colleen, your question is a great question. Let me repeat it so people don't have to read it. When a bird finds itself going away, they don't want to go. Do they go to ground and wait for a wind? They do prefer. Yeah, that's actually typically what happens. And one of the places where those wind changes occur is often at fronts. And those fronts are often where the precipitation is. So what we'll find is that even though I stated earlier, the precipitation is sort of a barrier, it is actually a barrier. It is more so that there's actually a front there and the wind direction changes. So then you end up in a bad situation for the bird to migrate and they'll go to ground. Good question. Okay, Larry. Let me step back to that map. You're asking the question about what's going on with the winds from the south. The winds coming from the south that meet the north winds over Oklahoma. Perfect. Okay, so this area here, actually, let me draw the line best. Follow my cursor, comes out like this. That is actually the warm front of this cyclone, mid-latitude cyclone that is occurring. It's the low pressure systems, it's the storms that you hear about on TV. That is actually a front. That is the warm front. In that case, the cold front would actually be this thing down here that is in New Mexico and Texas. Cold front, warm front coming out like this. I know you can't necessarily tell that. Meteorological wisdom is the best answer I can give you. Go check out some other maps, ask more questions later, and we'll go from there. So back to the American golden plover. On this day, 11 sightings of American golden plover happened in the Colorado Front Range. And this was just one day of that season. Typically, on average, according to eBird data over the last 10 years, it had been 10 sightings for the entire fall season of American golden plovers was typical. In this case, we had 11 showing up right along, 10 along the Front Range, one, out further near the Kansas border. Look at the reason why this might be. This is the map from the time that these birds likely deposited into Colorado. Let's start with talking about the origin. Where's the origin of the winds that are coming into Colorado at this time? Again, that green circle is my house here in Longmont, Colorado, to give you some reference. Where are those winds coming from? Throw it into the chat window because I don't have a question for it. There might be differing answers, and you might have to go and look at your Canadian geography to figure out what province is which. I've got Northern Canada. That's the cheap way out, Bill. Good job. Northern Canada is correct-ish, since you're being broad about it. I've got Alberta. I've got Saskatchewan. Oh, okay, North Central Canada. Thanks, Bill. Keep up the good work. So I see votes for Saskatchewan, which is this province here. I see votes for Alberta, which is this province here. I've got more votes for Saskatchewan. I've got votes for the Yukon way up here, Manitoba over here. And maybe this is a lesson in we don't know our Canadian geography. Maybe that's the case. The correct answer for where these winds are originating from. Ooh, thank you, Robert, for the central and eastern Nunavut. Much appreciated. So the answer is likely. Let's just track it back. Going through some of these winds here, and we're somewhat originating from Alberta. If we track different winds, this is where we come into the problem areas. Let's go back. And we end up once again in Alberta. If we keep going further south into sort of the Colorado Springs area, then you run into even wider path out here, and then maybe you end up all the way into the Northwest Territories and northern Saskatchewan. All of those answers are really good answers. I really appreciate the Nunavut answer because that means you know your Canadian geography. But unfortunately, there probably weren't any from Nunavut, which is this province up here in this case. Okay, so that's our origin. We've got a really far away origin. That's great. Bonus. What about our wind direction? And is this at the right altitude? Yes, this is at the right altitude. I'm showing you the correct map. This is the 850 millibar map for that day. And our wind direction looks really good. We've got north winds, north-ish, north-like winds coming into Colorado in this case. Let's zoom in a little and we'll have a conversation about the convergence. And hopefully this will clarify some of the questions that we've seen from previous instances. If we just talk about Colorado on the whole and where the winds are converging into Colorado, we could draw sort of a box around northeast Colorado from Sea Springs or so all the way up to the northeast corner, draw a box around that. If we track that area backwards, and we do that same thing that we did before by drawing a line across the winds, and we draw that line across the winds probably back up here from the Canadian Rockies in Alberta all the way through Lake Winnipeg over here in Manitoba. If we draw that line across there and we track sort of this square area backwards, you'll see that the eastern edge of that square, which would be most likely some of the winds that are way down here, are probably coming way out here, something like into central Saskatchewan when you hit that line that I drew before. If we go on the other end of this Colorado square, up in the Wellington area up towards Cheyenne, follow those winds backwards. And where do we end up? We end up over here along that line in Alberta. So the swath from here to all the way about over here in central Saskatchewan, there's the word I was looking for, that whole width of that line gets compacted into the Front Range. A significant difference in the length of that line. So in the calculations that I've done previously, it was about 900 kilometers initially and went down to about 100 kilometers. So you can think of it as a 9 times increase in the concentrations of birds that would in theory be in that air, compacted down into a much smaller area. Does that make sense? Either give me a thumbs up reaction. I'm not sure I can see those. Throw in the chat window if it makes sense. If it doesn't make sense, throw some questions in there. Totally makes sense. I've got some yeses. Thumbs up. Yes, wonderful. Thank you for being an attentive audience. Thank you for knowing where your chat window is and helping out the person who can't hear anything else aside from himself. Great, thank you. So it looks like things are going well. A question, what effect do temperature and precipitation have on this pattern of prognostication? On the pattern of prognostication, do you mean, I'm not sure how to answer that without asking more questions. So for bird fallout, what does temperature and precipitation have to do with this? So precipitation will make it so the birds in general will want to stop. So if there is precipitation at whatever point that is, it's a spot where they have this tendency to go to the ground. If the precipitation is light, they may go through it. We don't really know the answer to that. We know that they avoid the precipitation. In terms of the temperature matters very little to them. Birds are very good at regulating their temperature. And when you think about the efficiencies of a lower temperature, when they fly in lower temperatures, it actually makes their bodies more efficient. So it is good for them to actually find a low temperature by going up in the atmosphere. That's one of the reasons why they fly a little bit higher. They find this spot where their fat burning will actually be lower. They try to get as high as they can and have the winds at the right direction. Temperature doesn't really play a role. I know there's this feeling, this anthropomorphication of, that would be the correct word. There's a humanizing of the birds to say, oh, they're so cold. If it's so cold, then why are there still birds in winter here? The temperatures that this went down to, this system, for instance, they only got into the low 30s Fahrenheit. There's birds here all winter long. Yes, it may not be the birds that would be migrating through. It may not be American golden plover stays here all winter long, but the temperature isn't the factor here. Temperature control in birds is amazing. They have feathers. They do wonderful things with them. Rarely is temperature ever the problem. Do they ride it to the end is the final question from Linda. Do they ride it out to the end? They will typically stop until the winds come back to the right direction for them, or the precipitation stops, or you get a situation where it's appropriate to once again move. It may not be the greatest winds. It may be that they're searching for food and they can't find any, so they move on. So there is that sort of aspect to worry about. Think Dave Leatherman as much as you can. Food is the key answer. So it was the snow that lessened the food source for those that died. Yes, that is likely the case. And the temperatures for insects. So the insects will be down. It is almost all insectivores that died during the die out the other day. And they are often flight feeding. So lots and lots of swallows died. Swallows are all pretty much flight feeding. If they're not able to find insects in flight, they are going to have a lot of trouble, and thus they did. For the sake of time, I got to keep going. Thank you all for responding in the chat about understanding what I was talking about. Now, someone's going to ask me at some point, and someone actually did from the get-go before the presentation even started, where should I go birding? What habitat should I be in? Where is the exact location? And this is the best answer I can give you. This is super zoomed in on that American golden plover case. And what you're seeing is some areas where it is at a local scale, a small scale, extra convergent. So you'll find places like from Fort Collins down to approximately Boulder, because this is the 40-degree north line. Fort Collins to Boulder, you should see a good amount of birds converging in this case. The other place that would be interesting to go look is down here in the Colorado Springs up to Denver sort of area. And when we look at the map of where American golden plovers were sighted in this instance, it looks like this. So this is a much larger scale map. But you see the birds were from in Fort Collins approximately, down to Chatfield Reservoir. All 10 of the sightings were up right in that area that we were sort of looking at just a minute ago. And they were trying to move around from place to place to find a food source. It works great. It works super duper well. Finding those winds, tracking those to a spot where they converge, and look, there it is. These other black markers on this map are also American golden plover sightings. And some of them have to do with the cold front, which is right here, this blue line at this time. You can see that they're represented close to where that cold front is. All of these ones that are out ahead that are also black markers actually coincide with these other times that the front went through those locations. So you can see as the front went through, I changed the colors, but this is the most important one for our timing here of these birds. So the last thing I need to do is give you a summary, and then we can go into some bonus examples if people don't have any questions that they would like me to answer. So the three things that we've just talked about, 3.5. The wind direction at the right altitude. That's the easy one to deal with. That's the simplest one. You know, okay, I want a wind out of the north-ish, north-like direction for fall, and I should be looking 0.5 to 2 kilometers above the ground. The wind origin is really important. We saw that if it's just coming from Wyoming, yeah, it's probably not going to produce much for us. But if I get this other situation where it's Saskatchewan, Alberta, Great Slave Lake, up that area, then we're talking about a very different situation. The convergence that we just finished up with on that local scale gives you some great idea of where those birds should end up. It's time for your questions. If you don't have questions, or if you would prefer I go into some bonus examples, we can do the bonus examples. It is up to you. I am at your mercy. I should say thank you. Much appreciated for the invite, Nick, and others on the CFO board. Thanks for having me. I see the bonus examples are starting to win already. That's what I expected. Again, thank you all for your time. If people do need to move on to other things, I don't want to take any more of your time at this moment.
Folks, I will just jump in quickly to let you know 5 minutes mark starts now for anyone else who wants to put in a bid. Really, it does make a difference. And without having our convention and our typical sources for fundraising, this really matters a lot. And 5 minutes starts now with the bonus features, because I definitely want to see that.
So I've got one question that I need to answer because it is a really important question. Luke, thank you for asking it. How far will birds fly in a night? During migration, these birds are so hyped up on hormones that they will fly all night. They will often fly all day and all night to get where they're trying to go if the wind directions are appropriate for them. So the thought might be that 1,000 miles, that's too far for a bird to fly in a night. American golden plover is one of the fastest flying shorebirds in the United States. Supposedly averages between 45 and 60 miles per hour flying with no wind assistance. Put wind assistance behind it, and you can probably get that bird up to 100 miles per hour in terms of ground speed. 100 miles per hour, 12 hours of the night, just making an assumption to make the math easier, 1,200 miles in a night. It's really impressive how far these birds can fly. Sabrina, I'll comment on that at another time. I want people to get their bonus because they're asking for bonus. And Kathann, you're asking about the California and Washington fire smoke impacts on the insects. We can talk about that as well. Maybe I will do that offline, we'll see. So here's my next example. I don't think I set this up to loop. We'll let it play, we'll see how it goes. So here's my next example, and I want to ask you the question, one, throw it in the chat window as your answer. What birds do you think would be plausible to show up in this pattern in Colorado? I'm doing this sort of backwards. I'm asking what birds might show up here because of this pattern, not are the winds correct, are the convergence right? I've got Gloria saying Arctic breeders. That's a simple, broad answer. That works for me. Other people want to be more specific, want to give a try? I've got a vote on, or a question mark, ducks. I've got a vote for shorebirds, western gulls. Ooh, that's a fun one. Oh, Brendan, I think you're going for western gulls as in the actual species western gull, not just gulls of the West. Is that accurate? Just gulls of the West. Excellent. Okay. And I've got blackpoll warblers. That's okay, Brendan, don't worry. boreal forest breeders in fall migration. This is a fall migration pattern. It happens to be a September fall migration pattern. And in fact, it happens to be the Labor Day storm that happened that brought a few interesting things, like that what I will call the rough-breasted sandpiper in Fort Collins. That was a really interesting bird. I'm not sure we know what it is, and I'm not going to vote one way or the other. I see, Cindy, you threw in Wilson's warbler as an example. That was also showing up like crazy during this event. Other birds that showed up during this were red knots, little gull, red phalarope, sabine's gull, buff-breasted sandpipers, stilt sandpipers, and pectoral sandpipers showed up in a lot of different places. And sanderlings, very good, Diana. Thank you for bringing that up. They were also showing up on this day. The boreal forest warblers did make an appearance. There were a good number of Townsend's warblers that were showing up, but they were also showing up well before this occurred, which is sort of an interesting one that I don't understand yet. Townsend's warblers are really tricky for migration. I don't get them. I don't understand them yet at all. 1 minute remaining on your bidding. If you have bids, throw them into the chat. Don't miss out. So that was example bonus 1, and I'm going to stop there. So I'm going to return to the question about the fires and the smoke and their impact on insects. It doesn't seem to be that the fires necessarily, or the smoke, excuse me, necessarily affects the insects. It is hard to tell so far. There may be studies about it. I have not seen any. The smoke is all over the country, and I haven't seen personally a decrease in insect activity because of it. Oh, thank you, Diana. I should help you with using the website. You're right. I didn't do that. Let's pull that up real quick for you. So here is earth.nullschool.net. Let me make it now. In the bottom left-hand corner, when you click that Earth button, it pops up this nice menu. And you get the possibility of changing the time along this bar here. I hit now, and it brings me to now. Yours is going to show up in color, probably like this. The other thing that you're going to need to do is you're going to need to change your height from surface to 850. So once you change that to 850 millibars or hectopascals, same thing, you will see that the wind pattern looks like such. In the bottom right-hand corner of that Earth pop-up window, there's a little triangle that looks like a sort of compass. If you click on that, that will ask you if you want to use your location, if you will allow this website to use your location. If you allow it, it will put your circle, your green circle on there, and it will say this is your location, and you'll be able to see what that is. Congratulations, Kevin Ash and Allison. Good job. Allison Hilf, I believe, yes. Congratulations on the auction items, and thank you for your participation in that. The money will be well spent on the scholarships. So on that website, again, we can step through time. We can step forward in time, in fact, and find a day in the future that might be good for migration. Go ahead and step through and try that and see what you can come up with. Find a day that looks like it could be good for migration. Colleen, your question is, so when doing local convergence, do we change the pick to surface? In Colorado, staying at 850 is fine. Other places that are lower elevation than us, yes, going to the surface is useful. Good question. You do pick a different millibar value in other sectors of the country. When you're at lower elevations, you need to pick higher values of pressure. So the only options we have are surface and 1000 millibars, that is below, in height, below 850 millibars. So the best options are 850, 1000, or surface when you're away from Colorado. When you're in Colorado or at elevation similar to Colorado, use 850, and occasionally you can go all the way up to 700. Debbie, what about Iowa? The answer is likely you would use the 1000 millibars when you're looking at the surface. When you're trying to look at the winds between 0.5 and 2 kilometers up, definitely still use the 850.
With that, folks, we'll definitely keep getting some questions and whatnot, but I want to take the chance to thank you so very much, Bryan, for this wonderful talk. We had at least an average of 90 people most of the time, so that's a big audience for sure. We really appreciate your time. Allison and Kevin, we really appreciate your support of this program, and everybody else as well who was eagerly bidding as well. If you have to take off, you're welcome to do so. If you want to ask more questions of Bryan, I think that he seems ready to go as long as you guys are. Thank you all so very much. And we'll schedule something in December, likely early December, for a discussion about the Christmas bird count and how you can participate even if it's a pandemic year. All right, so any lingering questions? He's all yours.
Mary, your question, what would you use in Michigan? It's the same answer. We would want to use 850 millibars to try to look at that between 0.5 and 2 kilometers up. When you're looking for that localized convergence, you may want to look at the surface, actually. 1000 or surface, it'll be nearly the same thing. Cool, Diana, you've gone ahead and told me an exact time, 9:23 at 9 o'clock. 9:23 at 9 o'clock. I'm assuming that's local time, Diana? For migration this coming week at your house, got it. Dave, I'm looking into your question here. Assuming the winds are also from the north and west in spring, will you do another spring migration related meeting next March or April? I do actually have a talk lined up with, gosh, I don't remember what organization it is, but I am lined up for an April talk on this same kind of thing, but for spring. So definitely going to do that. Oh, Bill, you got to give me a tough question. I appreciate it. Let me come back to you, Bill. I want to check these other ones and then I'll get back. Given the lack of north winds now and tomorrow, would you expect the migrants that are here to stay? Luke, good question. I believe that most of the migrants that are here should stay because the winds are in the wrong direction. That's something we didn't talk about, the sort of reversal or the, like, how long are the birds going to be here? Those American golden plovers were almost all one-day wonders. Other examples that I've given, like the possible rough, the buff-breasted sandpipers, the red knots, one-day wonders. So they were there fueling up as best they could, and the winds were the right direction, so they just left. There are plenty of other examples where we'll get birds backed up against the mountains, and then the winds will not be the right direction for them to continue migration southward. And so they'll stick around for multiple days. That's what you need to be looking for. You need to be looking for those times where, oh, great, I've got them backed up against the mountains, and it's just going to sit there because the winds are the wrong direction over and over and over again. It's also a great way to find more birds that weren't detected on that first day. Go that second day and just keep trying, try different places. I know there's that whole Patagonia picnic table effect where people will go into one spot and just keep finding things. It's definitely true. It is worth going to some of those same places, but also note that there's probably other places that have a ton of birds as well. So try those. Coming back to you, Bill, do post-breeding migrants like the reddish egret ride winds up from the south? Probably not as urgent as seasonal migrants, question mark. I believe they do ride these. I look at the reddish egret record, and my first thought is Hurricane Sally. Birds will get out of the way of hurricanes. You will get a distinct lack of birds as a hurricane is coming on shore. And I would say that this reddish egret has a possibility of being affected either by Sally or by the current system that is down in the Texas area right now. I don't know its name or if it even has a name yet. I haven't paid attention. Bill, I think that answers your question. That's my feeling. I do think that a lot of these southern birds that we end up with in Colorado, like tropical kingbird, which actually was the exact same day that the American golden plover case was, that was the day that the tropical kingbird left. That is an example of another one of those hurricane probably induced ones, but you're getting this southern migrant on these really strong southwest monsoonal winds. So that's probably another good one to talk about. Given, we already did that one. How do you change the day and time again? Irene, I'm getting back to you. Hopefully you're still there. Back in this Earth button in the bottom left-hand corner, if you click the Earth button, there's a line that says Control. In that line that says Control, there's a Now button, which is now, and then there's backwards minus a day, there's backwards minus 3 hours, there's forwards 3 hours, forward a day, and then there's this calendar for all of you who are sticking around. You can actually go choose any date back into sometime in 2013, and you can check out any of those days. Go find one of those days that you had a great day and you're like, I wonder what the winds were like. There's your answer. It's a really fun game to play. Explain where this site's data comes from. I think you had explained that it is a predictive data, but is it from multiple current sites or data gathered over years? Oh, great question, Cindy. You are ready to open a Pandora's box, and I'm only going to give you a little view into Pandora's box. This is not real data. And I know like what's real, and we can have that whole conversation. This is model data. So this is from the Global Forecast Systems Model, GFS model. It is from NCEP, which I think Diana has listed down here as well. It is the National Weather Service's global scale model. That's the reason you can move this whole globe around and go look anywhere you want. This data is only as good as the model that produces it. And the model has a grid spacing. So if you think about what your I shouldn't go into grid spacing. The grid spacing of the GFS model is relatively coarse. It's very large. So it may not be super accurate in that super zoomed in view. So be careful with that. That's my one warning. It comes from the GFS. It's a model. It is not real data. You can actually go and look at real data with radars, with surface observations, with weather balloons, and you can sometimes see that this data on this website is wrong. So it's a fair warning, be careful. Yeah, Bill, definitely Sally timing is an interesting option. Whatever this thing is that's down there right now, I could look it up, but I don't know which one it is. That's also good. Got it, Cindy. So for those people who are still around, I don't see any more questions coming in, so I'm going to try one more thing. I'm going to give you another example. Oh, it's beta now? Oh, hell yeah, that's awesome. Sorry, disaster-loving meteorologist. That doesn't mean I enjoy the death. That means I enjoy the meteorology of it. Switching cases. Here's one of these other bonus ones while I've still got 50-some people on here enjoying this. I'll turn those colors back on. I'll move backwards and forwards in time. Here's another case. So on this date, this is the 16th of September, just a couple days ago, 3 days ago. This is 6 a.m. local time. What bird do you think showed up? or what birds do you think showed up in this pattern? This was just 3 days ago, so you could go back and look at cobirds if you needed to, or look at eBird and do it that way, or you could try to guess on your own and figure out what this pattern looks like it should be. I know I've probably lost you into the void of earth.nullschool.net where you're looking up other things. If anyone would like to answer, feel free. I will not be offended if no one answers my question about what bird possibly showed up or what birds showed up on this date. Brendan, you are spot on with one of the birds that showed up. Black-throated blue warbler showed up. But black-throated blue warbler was not found on this day. Black-throated blue warbler was found on the next day. Diana, you are right on. The answer is Connecticut warbler. This was the day that the Connecticut warbler showed up at Bar Lake. The next day, the black-throated blue warbler showed up. Was it actually present on the previous day? My guess is yes. And then they just happened to catch it in at the banding station the following day. It was one of those instances where the birds likely were going to stick around after the fact. Good job to those of you who are voting. I like the idea of Canada warbler. No one saw one, but I think it's quite possible that there could have been Canada warbler showing up. Let me rephrase. No one that I know of saw a Canada warbler this day. So those are all the examples that I have right at hand to play with. If anyone has any further questions, we're getting down to the number of participants where it is plausible for you to just unmute yourself. If you would like to ask questions, feel free to unmute yourself with that button in the bottom left-hand corner. And we can just talk about whatever you need. Bill, this website is not made for mobile devices, and they haven't figured out a way to get it there yet. So I am on my Mac computer, my laptop, I'm scrolling in and out to zoom in and out. Sally, your question is about wind patterns being typical year to year. The wind patterns change every year, so don't expect on a certain date that there'll be a certain thing. So you could actually navigate this website, go back on the calendar, and I could leave it at 9/16 of 2020 and then jump back to 9/16 of 2019 and see that the winds will be dramatically different. So you can do that exploration on your own to see that they are very different. How about the little gull? Rob, which one are you talking about? The one at Chatfield, or were there others, or was there a different date? September 11th, yes, Chatfield. So that was the same, let's go back to September 11th. September 11th of this year. There we go, apply. I don't think the bird, was it? I think it was there before the 11th, wasn't it? I thought Joey or whoever it was that had found it, it was on a previous day, but I may be wrong. Yeah, Rob, I don't know exactly when the bird showed up, or
didn't that show up on Monday, Labor Day?
I thought it was as early as Labor Day, because I remember there was the little gull, the red phalarope, and like 3 Sabine gulls all at the same time on that day. And so Labor Day was actually back on the 7th. And the timing that the winds were likely best were right there. 18 local time, so 6 p.m. on the 7th. So it may have shown up on the 8th.
Here's a question about the little gull. Where is it going?
Yeah, that's a great question. No idea where that thing's going. Do we know if it was, I didn't see what age it was. Was it a juvenile?
It was a juvenile.
Okay. See, that's part of the thing of the weather stuff. The weather makes it seems to be affecting the juvenile. It's not affecting the juveniles differently. It's the juveniles don't necessarily know how to deal with the weather, so they end up in these awkward places sometimes. That's my hypothesis.
Mm-hmm.
That is not necessarily the full answer though.
Well, they should want to go to the Atlantic coast, but they seem to be 180 degrees off.
I don't think it's really 180 degrees off. I think it's they started on winds that were going the right direction, and then those winds sort of turned in a direction that took them more this way.
Okay.
That's my feeling. I know there is the research that goes into that 180 degree turn, or sorry, 90 degree turn. Or is it 180? I forget which one it is. There is that research that says there are birds that have that 90 degree or 180 degree turn in their compass, and so they end up in the wrong spot. That's really intriguing.
Yeah, because the neat thing about little gull is that it's so regular every year.
Yeah, but they're mostly juveniles.
Right. Early in the season, they're mostly juveniles. We do get older ones later.
Agreed. So the little gull was seen on the 11th. Was it seen before that too, Rob?
Tell you what, does this work? I'm muted. Can you hear me now?
I gotcha.
So actually, it was found by Rick Olson at Chatfield, and I was there that first day, and it was found over by the South Platte Delta, and it moved around, and it was there for, I think, at least right around a week.
Yeah.
And I don't know if it was seen today, but I know it was seen relatively recently. But the 11th was definitely the first day it was found. I know, weird, huh?
It's weird because I'm just not remembering it correctly, I guess, because I thought there was a little gull there on Labor Day, like Nick had said.
I don't think so. That was maybe a previous year, not this year.
Man. Yeah, so I don't know why it was there on the 11th, because the 11th just looks like a funny day. Like there's not much going on. Here's the 9th at 6. Let's make it new.
I mean, it could also be a discovery thing, namely, it may have been there, but no one, observed the bird.
Right, but Chatfield is so birded, so
it
well
is.
birded.
You're right.
That I have trouble believing that.
Yeah, but I can tell you, for certain that the 11th was the first reported observation of this bird, and everyone piled on to that day because of you're right, the communication systems we have these days.
Cool. I don't know why the little gull was there that day. I couldn't tell you because here's the 11th at noon local time. Let's make it 6 a.m. just because
the winds are blowing
start
the
showing
wrong
up.
way.
I'm
Why
sorry?
don't you put it back 12 hours and see what the winds are like then?
So here's back 24 hours, and then I'll step forward. So this is 9 a.m. the day before, noon the day before.
The one question is, where is it coming from? Probably Hudson Bay, or maybe the Great Lakes.
And at no point during this time period do the winds suggest that anything should be coming from over there or from the north. And so this seems like it could be one of those, knowing the origin of the bird is really tough. Because what do juveniles do? They end up bouncing around all over the place. Maybe they go to Lake McConaughey. Maybe they end up at a lake in Iowa. Maybe they're just like bouncing around all over the place.
Yeah.
And
Well,
so
look, there is a circular wind from the Great Lakes going down to the southeast.
Uh-huh.
So maybe they hit that circular wind and that blew them west. And then they flew a while in the wrong winds until they landed.
I'm not going to disagree with you, Nick. The thing that I'm interested in is these are streamlines. And I don't know if in your work you know the difference between a streamline and a trajectory?
Nope.
Okay. These are streamlines, which is if you took a picture of a river flowing and you drew lines along the flow pattern of just that static picture. Trajectories are if you tracked an individual molecule of water down the river, it wouldn't necessarily go always in the path that the streamline went in, because the flow is changing throughout that river this whole time. So it's a from time step to time step tracked wind direction, if you will. I know that's a little hard to deal with, a little hard to understand. Did that make any sense?
Yeah, so you're saying the actual movement may not be what's depicted by these lines. These lines will affect whatever the movement is.
Correct. So these lines would be like, for this 3-hour period, the winds are going like this. And so if you think about it in terms of, let me try to pick a location here. I'm going to just pick one down here in probably Oklahoma. I think that's Oklahoma. So if 3 hours from now, so from this point, let's say 3 hours, this bird, whatever bird it is, flew for 3 hours, is going at 45 miles per hour flight, plus the wind speed, which is miles per hour, it's 17 miles per hour. So it's going to be going around 60 to 70 miles per hour. Multiply that by 3 to get where it should be after 3 hours. We should put it 210 miles north. So I'm guessing how far this is. I'm thinking it's going to be something like there. Now, if we step forward 3 more hours, now the winds are like this. So instead of what it was going to do, which was go this direction, now it's going to go this direction for 3 more hours. So let's put it there. And then we step forward again. And now these are the winds that it's in, and it's going to go 3 hours this way. And so it looks different than the pattern that it originally was. And that's what the trajectory is versus the streamline. Peggy, you're asking me on the chat about what is a streamline, and to define it again. If you take a picture of a river and you're able to follow sort of the flow of that river, but you just draw it on the picture, that is a streamline. It is an instantaneous view of the flow. So it's not aggregated over time. It's not what we just did here with the with whatever fictitious bird we're bringing in from Oklahoma. It's not that every 3 hours you change. It is, here's the view. This is where the bird should be going at that time and only at that time. Does that help, Peggy? And while, excellent, cool. Nick, did I help you understand the trajectories thing?
Well, not really, because you're telling me that you have to have some other information about which way the bird's moving and how fast it's moving to then calculate where you think it might end up.
Correct.
So
if you want to get really
like
crazy,
that would be a niche for you.
I'm sorry, I spoke over you, so I apologize.
There are probably no models for that, so that would be a niche for you.
Well, you ask for it, I'll give it to you. High split is the model that one would want to choose. It is available to run online for anyone for free. It takes just a matter of seconds most of the time, and you can run a trajectory model with forecast trajectories, or you could do it with archive trajectories, or you can do it backwards. And by that, I mean, you know the point that the bird ended up. And what if we did backwards trajectories to find out where that bird came from? That can be done. You can do it online. I will explain it some other time to anyone who wants to know. We can do an email thread or something like that. Feel free to ask.
Great. We can do this again next year.
There you go. If you're interested as well, high split can be used to predict smoke plumes. If you know where your fire is, you can say, where's my smoke plume going to go? It's another use of that.
Well, with that, I think we should probably wrap this up, Bryan.
Got it. Thank you, everyone, for your time.
Thank you very much. And Ryan did this as a volunteer, so we're greatly indebted to him for his support of CFO and everyone else's support as well. Thank you, and good night.
Thanks, everyone.